Hello, ayan, welcome sa ating learning module 3, Kinetic Motion, Newton's second law. This lesson is set for week 7 for our prelim, and after week 7, week 8, that is our prelim exam week na. So this is the last module for this term, for this period. Okay, so let's start. Let's start first with the objective. So the objective of this session or this learning module 3 or yung video na to, no, is to recall kinetic concepts, especially yung ating inertial frame of reference. So parang review lang din naman yung first part ng ating module. Then next is yung equation of motions na. So we'll be dealing with the coordinate system. So meron tayong 4 na coordinate system. So yung dalawa doon, na-discuss na natin last module and the previous modules, yun yung mas sanay tayong gamitin. And yung next two, or yung mga kasunod, ay yung matatakal natin mamaya-maya. Then yung angular momentum. So this is just a review of rotational kinematics. Yung ano lang, fundamentals. Kaya constant lang naman siya, di ba? Yung ganun. The next is the orbital motion. So, orbital motion, usually ito yung planets. Something with the effects of gravity sa motion ng ating body or particle, no? And the central force motion. And maybe I will divide this session or this video into 2. So, depende. Depende kung gaano katagal ko madidiscuss to or may explain sa inyo. Okay. Sige, start tayo, no? With the recall of kinetics concept. So, more in discussion tayo. Ayan. Newton's second law. Newton's law of motion. So, we have 3 laws of motion, no? First law is known as the law of inertia. The second law is known as the law of acceleration. And the third law is the law of action-reaction or law of interaction. So, dito sa first law, the particle originally at rest or moving in a straight line with constant velocity tends to remain in a state provided the particle is not subjected to an unbalanced force. So, ibig sabihin, magte-tend to move lang siya without changing in velocity, without changing in direction, unless a net force. Or yun yung ating unbalanced force. So, typical or yung usual error dyan is ang nasasabi lang naman or ang nababanggit ay, di ba, ganito siya. An object at motion stays in motion. An object at rest stays at rest unless a force acts on it. So, mali dun is yung force acts on it. Dapat net force. So, ibig sabihin, lahat ng force na nag-act dun sa object, hindi lang simply isang force. So, net force, pwede kasi in diagonal. So, we can have the rectangular coordinates niya. So, x and y. So, ganun. And next is yung ating second law. So, ito yung focus talaga natin ngayon. So, yung ating second law lang naman is more on the F is equal to MA. This part, ayan. Open natin yung drawing tool natin. Ayan. So, more on dito siya. Force is equal to mass times acceleration or summation of forces is equal to net force. Kapag in motion siya or gumagalaw, is equal to mass times acceleration. Yun. And next is yung ating third law, yung law of action-reaction. So, kapag may force na nag-act going to the left, merong force din na nag-act to the opposite direction, no? To the right. Ganun siya. And meron tayong mga naka-highlight dyan. So, mass is a quantitative measurement of inertia. So, yun, measurement daw ng inertia ang mass, no? And yung ating inertia is the measure of resistance of an object. So, na-measure yung resistance na yun by getting the mass of the object, no? Then, meron tayo dyan, force causes an object to accelerate. So, hindi si acceleration ang dahilan kaya gumagalaw ang ating mass, no? Katulad ng ating force is equal to ma. Force acted force acted on a mass or a body tends or makes the body accelerate. Okay? I guess na nabanggit ko naman na yan sa nung mga previous videos natin and sa mga synchronous sessions, no? So, ayan, dahil meron tayong mass, no? For example, this figure, meron tayong mass and may nag-act na gravity dyan, syempre, sa mass natin. So, mass times gravity is yung ating weight. So, ang weight natin is a force. So, this is a force. Okay? And si mass, ay mass. Or measurement ng inertia. While si force, si weight, ay isang force. Kasi, yung body natin ay nakakaranas ng gravitational force. Okay, ano pa bang meron dito sa FBD? And itong block natin dito, no? Makikita nyo, meron tayong mass na M, no? Meron tayong F dito, force, sabihin natin force. And we have the small f here, which is the friction. The N tends to point up, no? This is our normal force. And yung M, no, meron downward dyan. So, may nag-act dyan na gravity. Depende kung saang planet. Pero sa Earth, no, meron tayong 9.8 meters per second squared in SI unit and 32.174 feet per second squared. Yun ang ating gravitational acceleration. So, yung mga nasa loob ng box na yan, na green, not green, yung blue na box, ang tawag natin dyan is yung ating free body diagram. Or mas kilalang FBD. Ang free body diagram ay mahalaga para mag-solve ng kinetics problem. Kasi syempre, mas mahalaga na sa atin yung force, kung saan nag-act si force. So, kailangan natin ma-distinguish ano ba yung direction niya and ano ba yung magnitude. Kasi vector quantity siya. So, meron tayong magnitude and direction. So, yun yung mahalagang malaman natin. So, yung arrow tends to point or tells us kung saan yung direction, no? And ito namang nasa red na box, no? Hindi nyo namamalayan na nagagawa nyo siya. Yung nasa loob ng red na box natin is yung mass and itong A. So, ano ba yung A na yan? Yung A na yan ay yung ating acceleration. It is also known as the kinetics diagram. So, kinetics diagram, syempre, meron na tayong acceleration. Ibig sabihin, alam na natin kung saan papunta yung ating object. Kasi si acceleration ay isang vector quantity. Okay? Then next. Okay, next tayo. Inertial frame of reference. Inertial versus non-inertial frame of reference. So, since noon, nababanggit ko, bottom line, no? You can pause the video para basahin to. Bottom line, yung inertial frame of reference, ito yung masasabi nating stationary, yung observer, no? Stationary si observer natin. Meron siyang, ayan, yung frame na yon has zero acceleration. Ibig sabihin, hindi siya nagmo-move. Or pwede nagmo-move siya at a constant velocity, basta zero acceleration. Ang good example niyan is yung tayo sa Earth. No? Nasa Earth. nasa Earth tayo. Ayan. So, paano? Paano ko nasabi na inertial frame of reference si Earth? Kasi, at our standpoint, no? Kaupo ka dyan, nanonood ka ng video ngayon, stationary ka. Pero without realizing na yung Earth, 'di ba? Gumagalaw sa Earth. Nagro-rotate siya, nagre-revolve siya. Meron siyang sarili niyang orbit. Pero hindi siya accelerating. So parang normal lang. Ayan, parang stationary. So yung Earth is an example ng inertial frame of reference. Ayan, dito may example din. A train moving in uniform velocity. So yung keyword dyan is yung uniform velocity. Kasi kung nag-accelerate siya, iba na yun. Yung hindi na niya na-satisfy yung condition natin na to. Then yung non-inertial, ito naman yung nag-accelerate. So, syempre, non-zero si acceleration. So, kahit meron kang infinitesimal na sobrang liit, pero meron ka talagang acceleration. No? So, it is a non-inertial frame of reference na. So, dito, hindi nagpo-fall or hindi nag-obey si Newton's law of motion. So, meron tayong tinatawag na relativity, na general relativity. So, hindi ko naman siya masyadong i-explain kasi medyo complicated siya, no? Kung ibibigay ko yung left and right ng ating inertial frame and non-inertial frame. Pero for this subject, no, ang pinaka-focus natin is yung ating inertial frame of reference. So, meron tayong observer. Ayan. So, bakit nga ba kailangan to maintindihan? Kasi, meron tayong equations of motions. Equation of motions or mas gusto ko siyang tawagin as yung ating coordinate system. Okay, so we have sa other sources, meron tayong 1, 2, 3, 4, yung mga naka-highlight. Pero I tend to put an indentation kay normal and tangent natin kasi halos same lang sila kung tutuusin, no, ni rectangular coordinate system. No? Rectangular coordinate system, na-discuss na natin yan noon, yan si summation forces along x is equal to 0, summation of forces along y is equal to 0, summation of forces along z is equal to 0. Mga ganun. Or is equal to mass times acceleration. So we are tending to analyze our particle in terms of its rectangular coordinates along the x and x, along the y, and along the z-axis. So, yung kapag ginamitan na natin siya ng Pythagorean theorem, no? So, we can have, or we can compute for the r, yung parang resultant, to get its position. Okay, and then yung ating normal and tangent naman. So, NT coordinates. So, we have here the formula for FT. Yung T is the tangent. So, this is mass times the derivative of T, V over dt. So, this is acceleration. So, tangential. And Fn, ito naman yung m times v squared over r. Or yung v squared over r, ito mas kilala natin siya bilang yung ating centripetal acceleration. No? Centripetal acceleration, or pwede rin siyang maging m r w mr squared w. Saan to nanggaling? Check nyo. Recall nyo yung ating tangent and angular motion. And tangent and angular motion ng mga equations. No? Ayan siya, centripetal. And if you can see, no, ito yung plane natin for normal and tangent. So, bakit nandyan si normal and tangent natin? Yan, dahil si normal and yung ating normal and tangent plane ay isang example ng non-inertial frame of reference. Ibig sabihin, gumagalaw si normal and tangent plane natin. So, I mean, hindi siya exactly non-inertial frame of reference. Pwede siya kasi moving yung ating plane. If magkaroon siya ng acceleration, a non-zero acceleration, so non-inertial na siya. Ayun na, clarify ko lang. Hindi siya agad non-inertial frame, pero pwede siyang maging non-inertial frame if yung acceleration ng buong plane ay nag-move with a non-zero acceleration. Pero karamihan naman, I mean, sa mga nako-compute natin or kino-compute natin, sinosolve natin, ano siya, inertial frame of reference. Okay, then, what's next? Ito. Ayan, yung polar. Kung nagbasa na kayo ng module, na-encounter nyo na itong polar coordinates, no? Hindi siya masyadong nagagamit. Actually, kasi mas friendly kasing mag-solve using the rectangular coordinates, no? Without realizing na nagpo-polar din naman tayo. Pero, tina-transform lang natin siya talaga into rectangular. So, we have here the general formula, no? FR is the R. Yung R natin dito is the resultant, no? The resultant or the mas kilala natin siyang resultant kasi X and Y. So, yung kanyang resultant, small r. Then, yung ating angle. This angle is usually the angle from the horizontal or from the x-axis. Ayan, kaya dito. From the x-axis. Then, the z points yung parang location niya. So, kung ito, no, r and yung ating theta, pwede natin siya ma-resolve into x and y. No? Yun dito, mapapansin niyo to, hindi siya algebraically, ano? Because ang gagamitin natin dyan ay vector addition. So, yung vector addition, parang ito yung kanyang rectangular coordinates, no? Pero in terms of the change in the angle na siya and the radial distance. So mamaya, no? May section tayo for that. So, just a brief background lang para may heads up kayo. Ayun yung spherical. So, hindi pa natin siya ma-encounter ngayon, no? Buti na lang din. Pero maybe sa future modules, I guess. No? Pero para mabigyan kayo ng idea kung ano ba yung spherical na yan. So, it is just the resultant na, the big R. And ngayon, meron na tayong dalawang angle from the x-axis, then from the xy plane with the z-axis natin. So, yun na siya. Okay. So, going with the flow of your module, nagbigay siya ng tips how to analyze problems that involve the equation of motions 2D or 3D space. So, dito, diba, select a convenient inertial coordinate system. So, rectangular and normal tangent coordinates may be used. Now, draw free body diagram showing all external force applied to the particle. Resolve their forces into their appropriate components and components. Yan yung X, Y, and Z. If may Z, kung 3D tayo, then draw the kinetic diagram. Kinetic diagram, ayan na yung ating acceleration, diba? Then next is showing the particles in inertial force. F is equal to ma. Resolve this vector into its appropriate components. Again, appropriate components kasi gumagamit tayo ng X and Y and Z. Yeah. Then apply the equations of motions in their scalar component form. And solve these equations for the unknowns. Then last is, it may be necessary to apply the proper kinematic relations to generate additional equations. So, ma-apply din naman natin yung ating kinematics, no? Like if we'll be dealing with yung kanyang distance na, no? Usually sa distance naman yan eh, kapag si kinematics na. Okay, then may next yan, solving problems with empty coordinates. No? So, empty coordinates is usually used kapag meron tayong curve path. So, mamaya curve path. Bakit curve path? Pwede rin ba yung empty coordinates kapag circular na? Or kapag nag-orbit na tayo? Mamaya makita natin yung isang magandang diagram or figure para mas maintindihan siya. Then, establish the anti-coordinates system on the particle. Yan naman lagi. Then, draw yung ating free body diagram and kinetic diagram. Normal acceleration, yung ating centripetal, no? Kasi inward siya, positive and direction. So, next is the tangential acceleration. May act either the positive or negative t direction or the tangent direction. Then, apply the equations of motion scalar and solve. Then, yan. Pwede rin si kinematic relationship. So, we have this, diba? Yung ating A, yung ating acceleration for tangent and normal. So, v squared over r. Or r squared times the angular velocity. Ayan. So, dito, din sa module nyo, ang binigay na mga examples ay ating friction. So, syempre, dahil friction, mag-review tayo saglit for friction. Okay, friction is the retarding force that acts opposite of the motion or the tendency to move. So, in this figure, no, it shows the frictional resistance. So, dito, ang ginamit na symbols, no, instead of, awan ko kung saan ba kayo sanay, if you're using P or F. So, usually, pag big F is just the force, then yung small f denotes the friction. Pero dito, ginamit lang F dun sa book na to, no? And frictional resistance. Then, the next figure is the magnified view of the contact surface. So, hindi kasi lahat ng surface natin ay smooth. Maybe visually smooth siya, pero if you look using a microscope, no? Crooked yan. Crooked siya. So, merong magka-clamp or mag-hook yung ating surface, yung ating particle, yung ating body with the surface. So, yun yung ating friction na. No? So, ayan. Next figure. Ito, pinakita lang naman yung relationship or yung parang applied force and friction. So, you can see here that force applied with regards to friction is linearly, no, 45 degrees. So, yung linear na to is the static friction. So, no motion. So, static friction, no? So, from the word static, hindi siya in motion. So, it will reach up to a certain value ng ating friction. So, ma-reach niya yung maximum available friction. So, motion impending. So, not moving pa siya. After mo malagpasan yung value nung friction na yun, so, you will still feel motion. I mean, you will still feel, or the object will still feel a friction, pero kinetic friction na siya. Kasi nagmo-move na eh. Nagmo-move na yung ating object. Hindi na siya static. So, as you increase the applied force, so, lumiliit na rin yung friction niya. Parang friction felt ng object natin. Then, up to a certain point na Pag sa sobrang bilis, parang wala ng friction. No? Parang ganun na yung dating. Okay. Then, ayan, yung meron nga tayong two types of friction. Static friction and the kinetic friction. Yung ating general equation dyan, or general formula, is friction is equal to the mu, or the coefficient of friction. So, this may be kinetic or static. Then, N is the normal force. So, this is the force exerted by the surface. No? So, bakit normal? Kasi lagi siyang perpendicular force siya sa ating surface. O yung parang normal natin. Yung ating normal sa ating NT coordinates. So, di ba? 90 degrees siya. Or perpendicular siya dun sa ating tangent. Okay? Next tayo. So, this is figure 5.4-4. Ito naman yung angle of friction natin. So, yung angle of friction is the friction made between the friction and the normal force, no? Ayan. So, visually, no? Paano makukuha yung angle na to? Ano bang pwedeng gamitin? Tangent, no? Tangent, yung ating opposite over adjacent. So, ating tangent, sabihin natin theta is equal to the frictional force over N. Okay. Then, rearranging, F is equal to tan theta times N. Looks familiar? Kasi, ayan siya. No? Ito yung coefficient of friction natin. So, we can say that tangent theta is equal to the coefficient of friction. Okay? Ito yan, ano to? Parang standard na to na dapat alam natin. And next, what is next? Figure 5-5. So, impending motion, angle of friction equals angle of incline. So, this only means na hindi nagmo-move yung ating block, yung ating object. It's not moving, therefore, it experience static friction. Kaya hindi siya nagmo-move. Wala siyang motion. Summation of forces is equal to 0. Okay. Then, next is na meron tayong cone of friction. So, hindi siya madalas, no? Hindi siya madalas na-encounter. Kasi kaya naman na rin siyang ma-resolve with the other means. Pero pinapakita lang dito, ito. Ayan. So, kapag meron tayong cone of friction, so, pwede siyang hindi mag-move. So, with the reference of C and A. And N is the normal. So, balance siya. Ito yung loss of friction na to. Sinulat ko lang siya. No? Ginamit ko siya sa previous class ko nun. So, this is just the interpretation nung eto, 7 to. Okay? So, you can pause this and read the text, pero ito na yung parang pinaka-summary niya, no? So, pag friction daw is equal to 0, ang ating resultant ay equal to the normal. So, wala tayong angle, walang motion. Then, F, or friction, is lagging, opposing the motion. So, hindi natin alam kung saan direction siya. Basta, initially, no, titignan natin kung saan ba papunta si object. Papunta ba siya sa left, papunta sa right, going up, going down, sliding left, sliding down, sliding right, sliding up, sliding up. Ayan. So, lagi siyang opposing the motion. Then, yung ating coefficient of static friction is 0 to max. So, pag na-reach na yung max, so magpupunta na tayo sa ating kinetic friction. So, Fs is equal to mu Sn. Yun lang yung number 4. Ayan. The number 5, kinetic friction is constant at limiting value. Ano yung constant at limiting value? Ito yun. Ito na, pag may certain friction ka na may experience na constant, meaning kahit sobrang bilis na siya, sobrang taas na ng force applied mo, hindi na bababa yung value ng ating friction. So, yun na yung at limiting value natin. Then, Fk is equal to mu k n. Then, ito na yung nasolve natin kanina. Yung ating mu is equal to tan theta. Ayan to. So, you can use this. You can use this technique, no, na if you have a lot of text na medyo ang haba naman, you can write it as an equation. Para at least, pag nagre-review ka, one look lang. O nga pala, number 1, F is equal to 0, ibig sabihin, R is equal to N. Okay na siya. Unlike this one. So maybe, this may work for you. Hindi ko alam. So, try lang din. Try lang kayo ng mga strategies kung paano kayo matututo. So, ayan. Meron tayong examples. And in the figure, two boxes have identical masses for 40 kilograms, both experiencing a sliding frictional force or friction force with mu is equal to 0.15. Find the acceleration of the box and the tension in the tie cord. So, if meron tayong dito kasi, check natin if moving ba talaga siya. Kung ano bang gagamitin nating friction. Kung yung kinetic friction ba, yung static friction. Pero ang sinabi naman dito, merong tayong sliding friction force with mu is equal to 0.15. So, ito yung keyword natin. No? Sliding friction force, ibig sabihin, yung mu natin ay kinetic. No? What else? Identical masses. Meron tayong 40 kilogram. Then, pinapahanap is acceleration and the tension. So, ayan, no? Usual na pag-solve natin, right? The given and required. Given, meron tayong mass A and mass B, 40. Then, yung sa figure, meron tayong mga angles. Ayan. I-write na lang din natin yung ating kinetic friction coefficient. Then, yung mga hinahanap. Acceleration and yung ating tension. So, yung acceleration para sa box A and box B. Pero based dito sa ating figure, same lang sila ng connection. Therefore, same lang din yung may experience silang acceleration. Then, yung tension, iisa lang din. So, equal lang din sila. So, yung first step, no, gawa tayo ng free body diagram. So, this one. Yung this free body diagram is para kay point A lang. Then, pwede mong kay point B, pwede kang mag-rotate ng plane mo. Pwede rin hindi ka na mag-rotate. Okay. So, dito rotated siya. Meron lang tayong W, WX, WY. Pag dito naman, ganun din, pero medyo complicated kasi siya minsan pag hindi ka nag-rotate. Pero depende naman sa diskarte mo. Or depende kung saan mo mas may iintindihan yung iyong FBD. Kaya sinasabi ko rin sa inyo, maraming possible ways mag-solve ng mechanics talaga. So, ayan. First step, dahil ang hinahanap natin is yung friction, no? Meron tayong mu, meron tayong coefficient of friction, meron tayong mass, ayan. Kunin lang natin yung ating friction, yung value ni friction natin. Then, next is summation of forces along x. So, along this part. And so, yung force na yan, meron tayong frictional force, ayan. So, ito yun, may arrow yan. Yung arrow yan, frictional force, then yung tension. So, summation of forces is equal to net force is equal to MA. Dapat dito may net force yan. Net force. Then, T minus F is equal to MA. Then, iwan natin si T sa kabila kasi unknown pa siya. Lipat sa kabila, MA times or MA plus yung ating frictional force na nakasave kay A. Ayan. So, this will be our equation 1. Then, set naman tayo for B. Kunin ulit natin si friction. Pero dito, hindi na siya makukuha agad kasi naka-rotate or naka-incline ang ating system, yung ating block B. So, dahil meron tayong FBD, dito tayo magbe-base ng summation forces along the, sabihin nating x-axis. Ayan. So, ito siya. F is equal to mu kW cosine theta. And meron tayong theta na 30 degrees. Substitute everything. Then we will have frictional force at point P or at block B as 50.9743 Newton. And save that to B. Then ano na? Summation forces na ulit tayo kay X. No? Then we will have an equation for T. Okay. Then, i-equate mo lang si T. Yung dito, T is negative kasi kabilang direction siya. So, equate mo lang si T. Pwede kang gumamit dito ng mode 5.3. Tama ba? To get the value of T, so we will have here what? And magiging 0 pala si T, no? Then we'll have A. We can solve for the acceleration. Then, isa-substitute na lang natin yung value ni A dito sa ating tension equation. So, dito, makukuha na natin yung value ni tension. So, hindi siya multiple steps na madalas kapag ganito. Kasi meron tayong dalawang block. So, if we have 2 blocks or 2 points, no? Madalas magkakaroon tayo ng system of equation. Magaganto tayo. Or pwede rin mag-equate tayo ng dalawang equation, equation 1 and equation 2, para makuha yung common nilang variable. So, basta yun, pag nakita kayo ng ganito, pag dalawang blocks, usually, i-focus muna kayo. No? Focus muna kayo kay point A. Then, yung step 2 kay point B. Tapos, i-relate. Makukuha ka nilang common variable. Then, kapag nakuha mo yung common variable niyan, substitute back mo lang sa mga nakuha mo equations. Okay? Then, next, ayan. So, dito, medyo complicated na to, no? Tatlo, no? 1, 2, 3. This 1, 2, and 3. So, in a system shown in the figure below, friction and the mass of a pulley are both negligible. So, buti na lang, no? Friction is negligible. Kung hindi, kukumputin pa natin si friction. And paano natin siya kukumputin? Same kung paano tayo nag-compute dito. So, mahalaga si F is equal to mu n. Kukunin natin yan. Pero dito, negligible daw siya. So, medyo napagaan buhay natin. And the mass of the pulley, this one. Kung meron pa kasi itong mass, nako, problema ulit yun. Mas mahirap siya isolve. Then, find the acceleration of M2 if M1 is 300 grams. Then, the acceleration kapag si M2 naman ay 500 grams. Then, F or yung ating force applied, this one, is 1.5 Newton. So, given and required, lagay lang natin si pinapahanap kasi, di ba, si acceleration ng mass 2. So, meron tayong mass 1 na 300 grams, mass 2, 500 grams. Meron tayong force F 1.5. Pinapahanap si acceleration na 2. So, dito, paano ba natin siya makukuha agad? Paano nga ba? Naalala nyo from the previous module, meron tayong chord. Tama ba? Chord nga ba yon yung ating line? So, sige, kunwari nagsasolve kayo, hindi nyo pa naisip. Ganito naman yung usual steps natin, no? So, kunin muna natin. Hatiin natin yan. Hatiin natin yung system natin into 3 para ma-relate natin sila. So, yung 1, ito yung parang FBD natin. FBD and kinematics diagram. Kinetic diagram. Summation of forces along X is equal to M times A1. So, tension, no? Ito yun. Meron yan tayong tension. Tension, tas may A1 going there. And, so we'll have an equation 1 as 300G times A1. I'll leave that as equation 1. Then, dito naman tayo kay section 2. So, T1, dalawa yung line, dalawa yung chord natin na hati. Ayan. So, summation forces along X is equal to MA T1 times T1 T1 minus negative T1 minus T1 plus T2 is equal to MA. Ayan. So, meron tayong kasi wala namang mass no? Bakit naging 0? Kasi walang mass si ating pulley. Hindi si acceleration yung nag-0. Ito si M. So, we have T2 is equal to 2T1, equation 2. Then, pagpunta natin kay M2, meron tayong, ayan, T2 and F. So, we'll have 3 equations. So, dito, meron tayong 3 equations. Paano natin malalaman sa acceleration? Paano? Saan man nanggaling yan? Balikan natin. Substitute muna natin to. Substitute daw si equation 2 kay equation 3. Ayan. So, we'll have another equation. F minus 2T1 is equal to 500 grams times acceleration A. Meron tayo nito. Meron tayo nito. And meron tayong, wala tayo nito. And equation 1 and equation 4. Dito. Substitute natin. Then, makukuha natin si yung 2A natin. Pero paano? Balikan lang natin. Yung constraint motion, meron tayong line. Clear lang natin. I guess yung iba sa inyo alam na to, na nakapag-solve na or kung nanood kayo ng video dati. Ito, panoorin nyo to, si constraint motion. Pero, last module, nagawa nyo na siya. Baka nalimutan na lang. So, di ba meron tayong line, tong line na to, or yung rope na yan. Constant yan. Constant. Okay. So, paano natin malalaman yung relationship ng ating acceleration, no? So, pwede tayong mga distance na matatravel. So, this is ating x2. Ayan. Then, yung ating x2, x1. So, pag nag-move to, say x2, yung ating x1 din ay mag-move forward, no? And yung equal yan sa ating line. So, yung line na yan, paano makuha yung line? Ito. So, bali, x2 minus to x2. Tapos, x2 din siya minus x2 for a while. Meron tayong x2 na yan, yung haba nito. Tapos, paano naman natin malalaman yung haba nito? So, meron tayo ulit x2. So, x2 plus x2. Pero, maminusan natin yung x1. Okay. Medyo na minus x1 is equal to a constant value. Okay, simplify. Meron tayong 2x1, 2x2 minus x1 is equal to c. Anong ginawa natin dati? Nung pag in-integrate natin siya, differentiate natin yung length natin or magiging velocity siya. Integrate. So, makakuha na tayo ng ano ba? 2v1 2v2 minus v1 is equal to 0. Equate lang natin. 2v2 is equal to v1. So, yung ito, pag dinifferentiate natin siya ulit, now we will get naman yung ating acceleration. So, differentiate natin siya ulit. So, magiging 2a2 is equal to a1. So, ito yun. No? Same naman. Ito yung kanilang relationship. So, yan yung i-apply natin. Yung relationship na to, i-apply natin or isa-substitute natin dun sa mga values ng A1 or nung A2. So, syempre, kukunin na lang natin yung value ng A1 to. Kunin na lang natin siya as 2A2. Para at least, ang makuha nating value sa uli ay A2 na lang. Okay, ayan. Ito na tayo kanina, diba? Equation 4. Then, 4 to equation 1. So, ito. Dahil naka-A1 siya, substitute natin yung A1 daw ay equal to 2A2. Ito na yun, 2A2. Then, continue lang ulit sa system. Then, you will have the A2, which is 0.8824 meters per second squared. Okay. Then, last time, I guess, ito na rin. Meron tayong level turn. application din siya ng friction, no? Level turn or aka or also known as turning on level curve. So, ito madalas sa mga sasakyan, no? The safety of a vehicle in turning a level curve depends on the frictional force between the tires and the road pavement. So, frictional force ng tires and ating road pavement. So, we'll just equate frictional force and FC. Yung FC natin, based sa ating previous module, ay yung ating centripetal force. No? Bakit? Centripetal force tends to go diba? Outward, same lang naman sila ni centripetal and centrifugal, pero si car kasi natin, diba, meron niyang mass. Then, if we are going to do a turn, syempre, meron tayo inertia. Kasi inertia natin, gusto niyan mag-tend to go to a straight, to follow a straight line path. So, ano mangyari? Magkakaroon ng change in magkakaroon kasi ng change yan in direction. So, pwede nating itong FC na to as yung ating centrifugal. Pag centrifugal naman, opposite in direction ni centripetal. So, pag si centripetal kasi, diba, inward. So, si centrifugal natin, outward. Then, ang pipigil sa kanya is yung static or yung frictional force natin. Okay, balik. Equate lang. F is equal to FC. So, same formula yung gagamitin pero as centrifugal siya. No? So, yung centrifugal and centripetal force ay example ng radial force. Yung radial force, pwede siyang outward or inward. No? Ito yung ating origin. Pero si centrifugal, lagi siyang pa-inward. Si centripetal. Si centrifugal, outward naman. So, yung dalawa ay example ng radial force. So, going back, substitute natin F. Value ng F natin or yung equation natin for F ay mu Fn or mu n. Mu times the normal force is equal to mv squared over r. Ito yung ating centrifugal force. Then, substitute, ano bang value ni Fn natin, no? Dahil nga level curve, meaning wala tayong angle, walang inclination. So, makaka-cancel out si mass in both sides. Matitira tayo with mu times the gravity is equal to v squared over r. Then, i-isolate si ating v sa left side or pwedeng si coefficient of friction. So, we'll have two equations, 1 and 2. So, yung 1 natin, hindi naman necessary na kailangan niya siyang i-memorize. No? You can just stick with this equation. F is equal to FC. Alam mo naman yung values ni F. Formula ni F. Formula ni centrifugal force. Substitute na lang. Huwag nyo nang memorizein lahat. No? Yung concept lang para hindi kayo ma-overload. And so, makukuha natin mu is equal to v squared over rg. So, ito na yung ating coefficient of friction. Ayan, ito yun. Ayan. Tangent na yun, diba? Then, v is equal to square root of coefficient of friction times the radius times the gravitational acceleration. So, maximum speed makakuha natin. So, kung meron tayong level curve, syempre, paano naman yung syempre, ang gusto natin malagpasan yung maximum na speed na to. So, meron tayong mga bank turn. time check lang. Oh, mag 1 hour. So, I guess last na to for now. Then, proceed ako with another video mamaya. So, sa bank turn naman, nung familiar kayo dito sa aerodynamics nyo or sa inyong subsonic aerodynamics, meron kayo nito, bank turn. So, yung concept ng bank turn, same lang yan dun sa ating mga car. So, yung car natin, meron tayong ganito, naka-incline with an angle. Same pa rin si MG. MG natin is weight. Ayan. Comparison lang. Then next, meron tayong FN. Yung FN natin is normal sa ating aeroplano. It is the lift. So, yung FN natin, meron niyang components. Yung lift, no? Lift components. Ayan. The angle between na nabuo nung using trigonometry, makukuha natin yung value na to and yung angle in between the Fn and the Fny component. Okay. Then dito, kagaya nga kanina, 'di ba? Sabi ko centrifugal force. Centrifugal force siya. Same dito. Pero ang gamit natin equation ay yung pang centripetal force kasi nag-change lang naman yung direction. And so centrifugal force is equal in magnitude and opposite in direction to the accelerating inward centripetal force. Okay. So ano lang sila? Direction lang. Then how many minutes? Still have 3 minutes. So 3 minutes lang. Last slide for this video. Ayan. You can pause na lang din yung video, no? Ito na yung practice problem 1 nyo. So, yung thought process, naglagay ako ng mga steps dito. So, acceleration daw ng package from point A. This one is point A meron daw siyang 3 meters per second squared na acceleration. And assuming that the coefficient of friction is the same for each section. Okay? So, yung coefficient of friction daw dito ay equal sa point A equals sa point B. So, determine the acceleration of the package at point B. So, same procedure given and required. At point A, ito yung angle. Ito yung ating acceleration. Based dun sa ating statement, constant daw si ating kinetic friction. Then point B. To solution, summation of forces along y is equal to 0. Yung y na yan is yung normal and yung ating mg cos theta. Kasi hindi naman maangat. Yung maangat, di bumababa. So, we'll have equation for the normal force. Equation 1. Then, summation of forces along x. Summation of forces along x is equal to MA or is equal to a net force. Then, MA is equal to the summation of forces. Ayan. The mg and F. We know that friction is equal to mu n. Substitute mu n to F. We'll have this equation. Then substitute the value of NA from equation 1. This one. Then M cancels out. This M, and this M. Kasi meron siya in every term. Then, what's next? Isolate. And you'll have this equation na. Save it to equation 2. Isolate mu K. And you'll have equation 3. Then, from point B, no? Equation 2 still applies. Pero sa substitute pala yung variables as for point B. Okay, ito na siya. AB na siya. G sin theta B minus mu K G cosine theta B. This is equation 4. Substitute mo si mu K. Ito yon. This one, magiging ito siya. Then, substitute na lang yung values, yung mga constants natin. Then, you're good to go. Okay, so, hindi ko na-beat. So, 1 hour na siya. Okay lang yan. Wala tayong problema dyan. So, I guess I'll end the video for now para 1 hour lang. Take a break. Pahinga muna. Try to consult with your group mates. Usap-usap lang kayo, no? May naintindihan ba ako kay sir? Ganyan. Or yung sample problem, unahin nyo muna yung first part, no? Kung medyo nangangapa pa for this lesson. And on that note, see you in the next video.